All right, welcome back to our penultimate video on volumes. And in this video, we are not going to be doing any rotation. What we're instead going to do is we're going to stack shapes on top of another shape. So imagine that we've got the graph of y equals 2 sine of x, and I've tilted it because what I am going to do is I am going to place semicircular cross sections on this graph. Now the graph is y equals, sorry, my semicircles are not really that great. The graph is y equals 2 times the sine of x, and I'm just stacking semicircle after semicircle on this graph until I completely fill it up. So imagine, if you will, that there's another semicircle, another semicircle, another semicircle, and they're getting bigger each time. And if I think about this semicircle, my radius is equal to 1/2 the value of my function at that particular point. So each of my semicircles which has a radius of f of x over 2 and a thickness of delta x, because we are counting along the x-axis here, which means that my volume of a semicircle, which is pi r squared h divided by 2, because it is a semicircle. So I've got pi r squared 2 sine x over 2 squared h delta x divided by 2. All right, let's do a little simplification. That simplifies, and what I get is pi over 2 sine squared x delta x, because we're not d'ing quite yet. This is one of my semicircles. And now what I want to do is I want to add up all my semicircles, take the sum of, and I want to take the limit of the thickness as delta x goes to infinity. Sorry, I've made a whole bunch of videos in a row, and all of a sudden my brain went completely blank. So what do I have here? I have the volume is the integral from 0 to pi of pi over 2 sine squared x dx, which is pi over 2. The integral from 0 to pi of sine squared x is 1.57079637. And I may recognize this as, oh, look, that's actually pi over 2, which means that, in fact, this volume is pi squared over 4 units cubed. Now, you can actually do sine squared by using the cosine 2x equals, I can't remember what it is off the top of my head. I generally have to look these up. 1 plus over 2. So you could actually do the antiderivative of this, but I chose not to. I chose to just sort of wing it a little bit and then recognize that, oh, hey, that looks awfully familiar. So we get pi squared over 4. Let me show you a picture of what some of these might look like and talk about how we decide to set these up. So pasting in the picture, paste it up, there it is, pasting it in. Let's make it nice and big. So what have we got here? Well, what you will be given is you will be told, I'm looking for semicircles that lie between the function y equals x squared and the x-axis. Oh, okay. So my radius is x squared over 2. And I've got a semicircle. You might have squares. Notice that these are squares. that lie between y equals x squared and the x-axis. So the side of the square is x squared. You might have right triangles. So let me switch from gold because gold won't show. You have right triangles where the base is x squared. And you would need to be given a little bit more information about these right triangles. You might be told that the height is half the base, blah, blah, blah. There you go. And then we've got one more example where we're given rectangles. And again, the base of the rectangle is x squared. And you would have to be told something about the relationship between the base and the height of each of these functions. And then it's basically just the volume of the shape is the area of the shape times delta x, and integrate from a to b dx. Boom, you've got your volume. My classes, once we're done with the AP test, are actually going to build these. You'll choose a function, you'll choose a shape. You may decide to do a rotation, but we're actually going to do a project just to help us. It's fun, and we get to visualize all the slices or the discs or the shapes on our function here. All right. So my class, go ahead and do exercise 41A in the book. And I'll be back with the last video, which is going to be a quick recap. If you watched the previous video, you saw pretty much a recap of everything that we did, but I'll narrow it down a little bit more of the as far as the kinds of things that we can do here in order to find volumes of shapes. Thanks for watching and have a great day.